as I have mentioned in the previous lecture, that you don't have to know Python rigorously to solve this, build these models. You can always look it up and code it. So I will show an example, right? And I will also tell you in the process that even if you don't know programming, right, how easily you can, uh, do these things. You can build a model. Even if you don't know anything of Python, I will show you how to, analyze this stuff. Okay. So, so this is just, importing libraries. And okay, I will not go into the details of the libraries right now, but yeah, later on, maybe we can go into that. So this is an example of linear regression. So what I can do is that, so this is a data set that I'm reading, and this is the columns that are in their data set, the salinity and the temperature of water. So this is the first column. So let's see. So this is just reading with the data set, the first line, and this is just defining the columns. And so this step is defining the columns, and again, this step is actually printing the data. So by head, I mean it will just print out the top 5 rows of the uh, data set that you have. Okay. So it's a big data set. Okay. So you see, like, this is the columns that I said salinity and temperature are the columns that you have. So on this case, you have, like, if the salinity of the water is 33.4%, let's say, your temperature will be 10.5 centigrade. Or so this is your data that you have, right? You can watch your data like this. So this will be given to you. So don't no need to worry about that. You just have to know how to read the data, and this is done in this line. Okay. So pd dot read csv. Okay. So if you don't know Python, like, how can you come up with it, right? So if you can, like, just Google, let's say, pd stands for pandas. Okay. So pandas read csv. Okay. So the first link that comes is the pandas documentation. So I like, this is very helpful. This documentation of pandas and all other packages. These are very helpful, and I suggest all of you to, uh, whenever you code something, go to this documentation. You can get very detailed description of all this, you know all the functions that pandas have, right? So read CSV. Here you can see that, this function takes these parameters, right? You can use so much. You might use some of the parameters. You might use uh, all of them, or whatever you wish. So for example, let's say, file path. So here you have to give the path of the file, right? And then you have to describe, like, whether this file has any separators, for example, comma, or separated by comma, or anything. And then you have to say that this parameter talks about whether this file has any header. Okay, and what are the names of the headers, and so on, right? So all these parameters, you can get from here. So you can share the code. Okay, yeah, of course I can share. I will share the code again. You can, like, subscribe to my YouTube, or I will share the Google Drive link there in my description, as well as I think it is the same drive link that was used for week 1. I will share the code as well over there. And okay, so you can, like, play around with all these parameters, right? This is just to uh, read a CSV, or you can read any other file, and so on. So what I'm trying to say is that, these documentations are incredibly helpful, and even if you don't know anything of Python, no need to worry. You can always, just Google and come up with the first link that comes, and you can get a description here, right? And also, if you see the description here, also it will give, detailed description, like, what does this parameter mean, file path or buffer. I mean, as I said, it means the path of the file, right? Okay. And here you can read it up, and you can understand how to go about, right? So for now, this is our data. Okay. And now we are trying to plot and see like uh, how our data looks, right? So on the x-axis, I have plot salinity. On the y-axis, I have plot temperature. This is how our data right now looks like. Ignore the straight line, but this is how our data looks like. So this contains like I don't know, like 10,000s of points, and I've just plotted the points in this graph, right? So this is the function for plot. SNS stands for this library. So here I have imported the libraries. So Cbond I have imported essence. So that stands for uh, yeah. So basically, this means that from that library, you are using this function. From that package, you're using this function. So lmplot is the function in SNS library, and you just give the x-axis name and the y-axis name and the data name where the data set is stored. This is stored in df binary like this, and then you just plot it. Here, dot show just stands for plotting. So, is there any questions so far? We're just getting started. All right. Okay. So you see, so this is a step, which I will not go into very detail because if I have to explain, this is a whole lecture in itself, But this is a step which is, I would say, very important in real life data. And if you want, like, you can like comment on my YouTube, and I can make a separate lecture on this. But for now, I will say this is what is called the missing imputation, right? So in real life data, you when you do a survey, you get a data. I mean, you cannot have all the columns populated for all the observations, right? You will have some missing data, right? So this is a step where you handle those missing data. So if you have a lot of missing data in your model, the in your in your observations, the model cannot perform well in those situations, right? So you have to. Sorry, is there a question? Okay. So, okay. So I was saying that, so you have to impute those missing values, right? You have to replace those missing values by in some way, or, remove the observations altogether. Okay. So, so here I am using a method called, so this is fill. So this will fill all the missing values using ffill. So ffill stands for forward fill. So basically, it will just look what is the value in the previous observation, and if the previous observation is not empty, not missing, it will just use that value. So again, I will not go into detail. There are a lot of other ways to do this missing imputation, but this step is just to mention that this is an important step before you build your model, and you have to do this. Right? So after that, I'm separating my x values. X values are my parameters, my dependent variables, the features that we are going to use in our model, and the y values, that is the temperature. In this case, this is the temperature which we want to predict, and x values is our salinity, right? Uh, we just define that. We make an array out of it, and this is a simple thing. And again, if you want to go into what this does, you can just Google numpy. So np stands for numpy. You can just do numpy array, and the first thing that comes is your documentation for the numpy, and you will again get what are the parameters that you have in this. Okay, numpy array object d type copy and so on. You can get what these parameters mean. Okay. So again, these are so easy that you don't have to learn Python separately. Okay. Okay. So again, so this step, what you're doing in this step is that you're splitting your data into training and test set. So as I explained in the previous video, that your training data is the data where you train your model and then you test your model in those in the testing data, and you see the performance of your model in your test set. So here you are basically dividing your data into train and test set, And here you're defining the test size to be 25%, 0.25. So the total, let's say you have 100 observations, you'll have 25 observations in the test set, you have 75 observations in the train set. Okay. And then you're defining your model. Model is linear regression in this case, and you're just doing fit. You're just doing fitting the model and giving the x parameters and the y parameters. In this case, x train is your salinity, y train is the temperature of the water. And finally, you are printing the regression score. Okay. So what is the regression score in this case? So this is giving an output to be zero point 0.2. Okay. So this is basically your accuracy. So your model is 20% accurate, right? Not a good model, right? So what is the score that you are that it is giving out? So we have not come across this score in the lectures, right? So I would say this is so if you have heard about it, this is called the R square score. So has anybody heard about what is R square? Can anybody explain? Okay, if not, I can just yeah. Yeah, 1 minus RSS by TSS, right? So R square basically is 1 minus RSS by TSS. So what does like RSS and TSS mean? You know, so RSS stands for residual sum of squares. TSS stands for total sum of squares. Right. Let's write down. Okay. And how do we calculate RSS? Okay. How do we calculate RSS? So you will sum over all the observations and you will take the difference between the observed value and the predicted value and then square it. Okay. This is very similar to the cost function, but you would see that we don't have any 1 by 2m factors or something like that. Okay. So this is the residual sum of squares. So what does it mean? It means that your model is not exactly fitting. So you have some residual, you know. So if your model would have exactly fit, then your yi observed. So these are the observed values, and these are the predicted values. So if your model has exactly fitted the observations, then your observed values will be equal to predicted values, and you will have no residual. You will have zero residual. So in that case, if you have zero residual, your R square value will be 1. That means 100%. So that means your model is 100% accurate, right? But you cannot have a 100% accurate model. So you will have some R square between 0 and 1. Now, what is TSS? So TSS is again summation over all the observations. Here you do yi observed divided by yi averaged whole square. Okay. So this is the again. So this is the observed value. This is the average value. Okay. So this is the average of all the y values, and this is the observed value. This is okay. For those who know, this is more like a variance kind of a term. But yeah, if you don't know about what is variance, then don't worry about it. But okay, so what does R square give? It is basically normalizing this residual sum of squares, the residual error that you have with respect to the total sum of squares, and then it is subtracting it from 1, and that will give you the accuracy of your model. So R square gives you the accuracy of your model, because you are removing the error from your from 1, subtracting the error, and you are getting what is remaining is your model accuracy. So that is the score that was given by uh, you know in the code. Okay. So this point 2 that you see is the R square value that you get based on this model. Okay. Now let's plot like how our model has fitted the data, right? So if you can see from this diagram itself, right, the model has fitted the data very badly. So the black line is your regression line, and this blue points are the observed points. So you can also see it from visually that your black line has uh, fitted the data very poorly. Okay, right. So this is an example of a poor model. Okay. Now we'll see like what how does a good model look. So what I'll do is that take a subset of that data only. This step stands for taking only the first 500 observations out of the whole data and making another data set out of it. Okay. And then again, let's plot the data. And as I was mentioning earlier, the LM plot stands for plotting the data from this Seaborn package. And again, x axis is salinity, y axis is temperature, and you see how the data looks like. Right? So these are the observed points. So this is just for the first 500 data points, right? This is for the for the first 500 data points. Our again, ignore the blue line, straight line here. You just see how the points are distributed. Okay, so these are the first 500 points, and this is how the data looks like. And like if you can see visually, right, that you can easily fit a straight line through these points. That can be done. And we'll again like make a training set and test set for this using these observations, and we'll fit the linear regression model, and we'll see how the R square score is. Okay. So again, we are splitting it into training and testing set, taking only 25% of the uh, population in the test set. So I will give the, yeah. Uh-huh. Yeah. So ignore this curve. Yeah, yeah. This curve you can just ignore it. So this is just for this thing. So you can fit a straight line as well. So this is just for visualization. So ignore this line for now. We have not fitted a model here. Okay. So that's why I said ignore this line. This is just generated. Uh, by this thing. Okay. So if you can fit a fourth order here, like this is just visualize, right? This is not the fitted line. Okay. You just see the distribution of points. This is just to, before you build your model, you just want to have an idea of how your data is distributed. So you just plot your data and just see. Okay. So this is part of pre-processing that you do. You don't fit your model. You haven't fit your model till now. Is that okay? So ignore the line and just see how your data is distributed. So from this distribution, we can see, okay, we can now fit a straight line. I mean, we can visually, have an idea. Right? This is just to have an idea. Now what we'll do is we again do split it into test and train set. And, this is we're defining linear regression model by REGR, and we're just fitting the model here. So this is where the model is getting fitted, this line. Okay. So this is where you're giving your X train and Y train, and your model is getting fitted. And again, after the fitting of the model, you're printing the score of your data. Now you see your R square value is 0.86, right? So your model is now 86% accurate, right? And even if you want to see, but from this is the fitted line, okay? So the earlier straight line you just ignore. This is the line that you have fitted using the linear regression model, and these are the data that you have. Now you can see, okay, now my model looks better. Okay. And also from the accuracy, you can see, okay, this line is showing, 86% accuracy. Okay. So this is all about linear